Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. Today we will learn a new topic on the analysis of arch. So this topic is a topic 5 according to the lesson plan. So without further ado, let's start the lecture with the learning outcomes. So in the learning outcomes, they have 4 things that you should to grab once we have completed this topic. So the first point is determine the rise y at each point of arch. And the second is to determine the support reaction of a statically determinate 3-hinge arch. And the third point is find out internal forces such as radial shear force, bending moment, and normal thrust values in statically determinate 3-hinge arch. And you should be able to draw the bending moment diagram, shear force diagram, and normal thrust diagram of a statically determinate 3-hinge arch. Okay, so as an introduction, let's look on the what it means of the 3-hinge arch. Okay, so sometimes we can call this as a 3-pin arch. Okay, so the 3-pin arch is used for large span of structures. Okay, for instance, let's say we have bridge structures. Okay, in construction, sometimes you can see that the truss can be constructed in terms of the arch shape. Okay, so they have a reason why this shape is adopted in construct the bridge. Okay, this is due to the ability of this shape to carry transverse loading efficiently, and by using this shape, okay, the bending moment can be greatly reduced due to curvature of arch, and we will look on this technically in the following slide. Okay, so almost similar to 3-pin portal frame. So actually this 3-hinge arch, the concept of analysis is almost same to the 3-pin portal frame, and the restraint on both ends to reduce the horizontal thrust. Okay, so this can be seen in the next slide. Okay, so this slide is try to compare between a beam and arch. Okay, so you can see at the left hand side here is a beam that loaded by the load. Okay, so meanwhile at the right hand side here is a arch structure that loaded with the same value of UDL load. Okay, so this is a point where you can compare between the beam and the arch. Okay, so at the first point you can see that the horizontal force doesn't contribute to reduce the bending moment. Okay, meanwhile in the arch, the horizontal forces exist and reflect to reduce the bending moment in the structure. Okay, so and due to these horizontal forces that not exist in the beam, so the large bending moment tend to have bigger size of member. So in comparing with the arch, okay, smaller bending moment as compared to beam. Okay, hence result the smaller structure size to carry the same load as the beam. So the key point here is about the horizontal reaction or horizontal thrust. Okay, so based on this slide, you can see that the comparison between a beam and arch. Okay, so we will see how this comparison between the beam and arch technically. Okay, so the left hand side here is the arch diagram. Okay, and meanwhile at the right hand side is the beam structure. Okay, so based on this load condition, that you can see that we consider this similar span and similar load condition where we have a W1, W2, W3, which is represent for the external load. Okay, so by okay, let's relook on the arch first. Okay, so by cutting up this arch section, okay, you and by taking a moment at the point P here at the cut section. Okay, so we have internal moment, okay, of arch. Okay, so in counterclockwise, and we have reaction, okay, multiply with the y, and this will give a moment due to this horizontal reaction, and we have vertical reaction here. Okay, so this will result the moment due to the vertical reaction, okay, at the support, and we have counterclockwise of moment of loads. Okay, so this moment of load is according to the W1, W2, and W3. Okay, so and rearrange these equations, so you can see that the M arch is plus Hy equal to Vx minus moment of loads. Okay, so this is a first equation. of an arch. Okay, so we will compare this equation with respect to the beam later on, and let's focus on the beam. Okay, based on the same span of beam with respect to the arch, okay, and the same condition of the load, which is W1, W2, W3, and we doing the same thing, and by taking moment at the cut section equal to 0. So right here we have a internal moment, okay, m beam, so in counterclockwise, okay, plus with the vertical plus with the moment due to the vertical direction, okay, right here this will give us clockwise direction. Okay, so and summarize of a moment of loads here. Okay, so due to W1, W2, W3. Okay, so and rearrange this equation, you can see that the m beam is equal to Vx minus moment of loads. Okay, so basically we can equate both of this equation. Okay, so the equation from the arch and the equation from the beam. Okay, so this both of our equation can be equating by looking on the right hand side of equation on each beam and arch here. Okay, so you can see that for the arch we have Vx minus moment of load at the right hand side of the equation. So and the same thing happens in the beam. So we have a Vx minus moment of load at the right hand side of the equation. So by equating both of this equation, you can see that we have m arch plus hy equal to m beam, and rearrange this equation, you can see that m arch equal to m beam minus hy. Okay, so this proves that the bending moment in an arch is very much less than the bending moment in a beam. Okay, so for example, let's say we have some value here of hy, and we have some value of m beam. Okay, let's say m beam is 10 kilonewton meter, and the product of hy equal to 5. Okay, so 10 minus 5, this will give me a 5 kilonewton meter value of m arch. Okay, so which is lesser than the value of m beam, which is equal to 10 kilonewton meter. Okay, so based on this equation and based on this slide, you can see that the comparison between a beam and arch. How in the arch we have a lesser bending moment value than the beam. Okay, so let's continue the lecture with the internal forces in the arch. Okay, so based on this diagram, okay, based on this free body diagram, you can see that this is a internal forces in the arch. Okay, so you can see that we have a radial shear force, we have the axial force, and we have a moment. Okay, so it's basically similar to the internal forces in the beam, but the difference is only on the orientation of the axial force and the orientation of the shear force. That's why in the arch we didn't call it shear force, we call it radial shear force, because this shear force is oriented in different angle at different position along the arch.